This video will cover the ALEX topic Introduction to Exponents. So let's define what an exponent is, look at some examples, and then evaluate some exponents. So an exponent is a whole number that indicates how many times a base number is to be used as a factor. So for example, if I have 8 cubed, that's telling me I want 8 times itself 3 times. And writing 8 3 times isn't so bad, but what if I had something like 6 to the 14th, right? If I want to write out all those 6's 14 times, that would take a long time. Also, that's a very big number, so I might not want to evaluate it, right? It's not what I know off the top of my head. So, like my joke is, mathematicians are lazy, so we developed this, exponential notation. So let's take a look at a few examples of exponents. So here I have 9 squared. If it's to the second power, we call it squared. If it's to the third power, we use to call it cubed, right? That comes from the formulas for area and volume. Thinking back to geometry, if you've taken that already. We could have 5 to the first power, 3 to the fourth power, and 9 to the 0 power. And we want to practice evaluating some of these exponents. So let's look at this next example. So I want to evaluate the following. So the first thing I'm going to tell you right off the bat is it's always good to know the first few perfect squares and then the first few perfect cubes, and then the rest you'll probably see so much that they'll become second nature. So the first few perfect squares are 1, right? 1 squared 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, 36, 49 is 7 squared and onward, right? Those are the perfect squares, and those are good to know. The first few perfect cubes would be 1, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. And it goes up from there. So if I have 4 squared, that's 4 times 4, which is 16. If I have 3 to the fourth, that is 3 times 3 times 3 times 3 times 3. Now you don't have to write all this back out, but so that's essentially 9 times 9, which is 81. 5 cubed, 5 times 5 times 5, that's 125. 5 times 5 is 25. 5 times 25 is 125. Think about quarters. If you had 5 quarters, you'd have $1.25. Well, but now it's 125, so ignore that decimal point. And then I have 2 to the fifth. 2 times 2 times 2 times 2 times 2. Okay, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So our final answer would be 32.